Welcome to Delta Computer Systems webinar series. Today, Applications Engineer David McNichol is going to be demonstrating some ways to figure out why a motion system either isn't operating at all or not operating in the way it's expected to operate. Thank you for taking some time to be with us today. A recording of today's presentation will be available in a number of places after the session, and we'll cover where to find those places at the end of today's program. Questions are encouraged during the session. Please use the chat window to enter your questions, and we will try to answer as many live during the presentation as we can. And now I'd like to hand it over to David to begin. Welcome, David.
Thanks, AJ. Yeah, welcome everybody, and thank you for joining us in our webinar today. We're going to be covering troubleshooting, but this is going to be more of a basic troubleshooting webinar. So where some of our webinars in the past have focused more on advanced features, our focus today is going to be on the basics. Perhaps you don't use RMCs all day. Maybe it's something that you only crack open every 6 months. Well, this webinar is going to be for you. So we're going to cover features like plotting, access tools, event log, status error bits, things like the no transducer bit, transducer overflow, following error. If you're familiar with RMCTools, most likely you've seen many of these error bits pop up. Output saturated, that's another common one. And then just programming logic in general, what it's going to take to get to where you need to be. So here's some common issues that we'll see. Very common to see the no transducer bit. I'd say this is probably the error bit. This and the following error are the two error bits that you've seen most likely most often. Miswiring is a big problem, and we're going to talk about that as we go through. Transducer overflow, another one. Following error, output saturated. Programming logic errors. And again, I just really want to nail down, these are the basic issues that we see most often, and this is what we're going to be focusing on today. Now, if you're totally unfamiliar with Delta RMCs, or if you just like a refresher, want to make sure that everyone knows we've got a nice video series on our website. A great way to refamiliarize yourself with Delta RMCs, or just as a complete new introduction. You can see there's quite a few different parts here, and we go all the way through from basic motion to getting your controller programmed up and running in a production environment. All our past webinars are also available from our website. We've got a schedule of upcoming webinars, and you can see that we've got some great webinars that we've already done. If you'd like to view these at a different time, they're all available here. So here's our example that we're going to be running through today. I've got a few physical elements to the example and a few simulated elements. But our system specs, we've got a single cylinder. We're going to have analog position feedback. Now, if you know Delta, you know that analog position feedback is not what we generally recommend. Sometimes it's the only option, but generally we recommend using SSI for position feedback. We're using analog today because it's more common to run into errors, and I'd like to show what it looks like when you've got something funny going on with your feedback. And we're just going to have a standard servo proportional valve on our setup here. So very simple, single cylinder, single transducer, single valve. Our objective is also going to be simple. We want to run cycles moving between two positions, and we'd like to hold positions within 1/100th of an inch. This system, fast motion, capable of moving at 30 inches per second. So it's just your standard cylinder, nothing too crazy. Very simple example. So here's our scenario. What we know about the problem. It doesn't work, right? And it's very common that this is all you're going to know about the system at the time when you're looking at it. Hopefully you know more, but it's very likely that you get the call, the system doesn't work, and you kind of need to just go in there knowing very little information other than it's not running cycles. Again, what we know about the system, we've got our system specs that we know, and we know our objective. So we're going to, knowing what we know about our system specs and what we know about our objective, we're going to try to troubleshoot through and see where we can get. We've talked about this troubleshooting flowchart a bit in the past, but I want to reiterate it here. We're going to be using this troubleshooting flowchart pretty much the entire webinar. It's a fairly simple chart, but very, very nice. Um, if you've got a problem, tracing through this is going to point you in the right direction. We actually have an expanded version of this available as well. That's a bit more interactive. It's got hyperlinks to our help topics. If you'd like a copy of that, let us know. I'd be happy to send you over a PDF. But we're going to be tracing through this based on our errors. So before I get into this, what I'm going to do is jump to RMCTools. And I've got a project here. So the axis we're going to be focusing on, just double clicked on axis definitions to bring this up. We're going to be focusing on this axis 0. Again, if I look at my definitions, this is just a single loop, right? It's that single cylinder, 1 voltage output, and an analog input coming from our A8 card. So very simple axis. You can see I have a few more here, but we're not going to focus on these for this webinar. Okay, so usually the first thing that happens when you go in, you'll look either at your error bits to see, is there something amiss there, or someone might try to run a cycle and show you what the problem is. So we're going to say perhaps everything's been reset, maybe none of the error bits are on. I'm going to try to run my main program. I'm going to try to run a cycle, and we'll see what happens. So we get this little error button that pops up here. What I would normally do is consult flowchart. Let's see what we have. So what's the problem? Well, it's obviously it's not moving, right? It's not moving, it's not working. We got that halt condition as soon as we started. So this is our first step. Next, what we're going to check, it's moving but not doing what it should be. Well, that's not the case. It didn't move at all. It halted as soon as we started. Do we suspect hardware? It could be, I mean, possibly, but generally if you're getting a halt, it's not going to be a problem with the RMC hardware. It's definitely not moving. So what we have to do is check and see if any of the error bits are on. So I'm going to come to Axis Tools here under Axes. I'm going to open up my error bits, and I can see that there's a few different errors that I have. I'm just going to go ahead, we'll work our way down, and we'll start trying to clear these. So what I would do here first, and again, if you look at our flow chart, you can see that the error bits are on, error bits are on. Let's see the error bits help topic and see what it tells us. So first, for the no transducer. Many of you have probably seen this, but you click anywhere in RMCTools, you press F1, and it'll bring up a help topic. So I just hit F1, help topic came up here off screen. But what I have is a no transducer. So I'm going to look at no transducer. I'm going to see what kind of feedback I have. We have analog voltage, and we have an RMC 200. So for a 200, no transducer means a broken wire is detected. So what I would do here at this point is I would check my wiring, make sure that everything is set up correctly, and try to move on to our next condition. Now, in this case, I know that it's already been set up, that the wiring is incorrect. Just to show you that it's not set up here, what I'm going to do is a Control-Shift-C. That would clear any error bits that are no longer present. You can't really see that I'm doing this, but I'm pressing Control-Shift-C. You can see that that command error went away because that condition is no longer present, but the no transducer and the transducer overflow, they're still there. So I'm going to go over to my physical system, change my wiring, and let's go ahead. We'll hit Control-Shift-C again. that no transducer bit is gone. All right, so we've solved that problem. But again, following the same logic through our flow chart here, well, we've got a transducer overflow. So let's again go back to our help topic. Transducer overflow. This is analog voltage still, right? RMC 200. What we have is the voltage is above the analog overflow limit. This is something that's more specific to the RMC 200, and it's something that everyone might not be familiar with. So what I'm going to do is look at, well, what is my analog overflow limit? Maybe you're new to RMCTools, you've never heard that term before, that's fine. Our help topics are great. If I just click on analog overflow limit, it'll bring you right to that help topic. It'll show you exactly where that register is. So for instance, how to find access parameters pane, alt tab, feedback, or secondary feedback. So let's jump to RMCTools. I'm going to go to my access parameters, alt tab, and then my my feedback tab right here. Already had it open. Analog overflow limit. So what this is telling me is if my voltage is over 10.1 or it's under negative 10.1, well, then I'm going to be getting this transducer overflow bit on. So what I would probably do here is look at my feedback, and I want to see, well, what is that voltage actually at right now? It's at 10.5, and that's our max limit. So I know that it's at least past 10.5. That tells me there's most likely a problem with my transducer, and at this point I would go out and I would check and make sure that everything is correct, right? That our wiring's correct, and I would probably take a multimeter and check to see between our input plus and our input minus, am I actually getting the voltage that I would expect? Because 10.5 doesn't seem like what we should be getting. So I can tell you here that my voltage right now feeding into the RMC was set to around 11 volts. I just turned that down to 9 volts. I'm going to clear this error bit. You can see, okay, now my transducer overflow, that's gone. So I've got no error bits at this point. Things look good. It looks like we're ready to try to run a cycle, right? We're ready to start moving. So at this point, I'm going to try and run our main program again. And you can see immediately everything's halted. Let me do this so that you can see exactly where our transducer is. Okay, so we're looking at axis number 0 here. If I run this program, you'll see it doesn't move at all, right? It's not moving. So let's jump back. We're going to jump into our flowchart again. And again, what's the problem? Well, we still go down the same path. It's not moving / working. I'm going to check to see if any of the error bits are on. And we're going to see that we've got a following error. I don't know if you guys caught that. I'll show you here in a sec. But the little bubble that popped up in the corner says we've got a following error. So first thing I'm going to do, know that I've got a following error. It's moving but not tracking the target well. That's what the following error means. I'm going to see the tuning topic, and we're going to go through. We're going to try to tune this up. We're going to make sure that everything is working correctly. Now this one is a little bit more tricky, and just trying to tune things up, we're going to run into some more problems. So if I continue along here, what I'm going to want to do, and this is a tool that that we always recommend, right? If you're having a problem with tuning or with tracking, a good place to start is just trying to plot your motion. So I'm going to go ahead here, and I'm going to start to plot my motion. Okay. So now I can actually see If you're not familiar with RMCTools, just clicked on this plotting icon here. You get default plots for each of your axes that you have set up. And so I'm just trending a default plot. The red line here, this is my actual position, and the light blue line is my target position. So let's look at those two first. If I zoom in here, I can see that my target is starting to move, and my red line, well, it's not moving at all. Now this could tell us one of two things. Either we have no gains in the system at all, so we're not getting any voltage to our system, or maybe something else is miswired. So let's look at our control output. Well, this is the output that's actually going to the valve. So this valve it's actually being opened up, and it goes all the way to 30% before it starts to ramp back down. And so what this would tell me is either you have a valve with more than 30% deadband, or there's something else going on. And so for us, it's telling me that, well, maybe our transducer is still miswired. So I'm going to go back in, I'm going to hook this up to our physical transducer, and you'll see how this changes. All right, so now I'm hooked up to a physical transducer, and things should be looking better here. So let me trend this here. A physical setup that I have, just to give you guys a little bit of input. I've got a really small load cell just on my desk here. I think I saw Nick Tolley in the group here. You know which one it is if you're here. But I've just got a very small load cell, just something to show that we've got analog position. And so now I can see I'm moving this around, and I can see that I've actually got position coming through. So things look good here. So all of that is just to show that it can be very confusing, especially with analog position feedback, to try and tell, am I actually connected? Is there a problem with my transducer? Am I okay? It can still be very misleading, because even if the error bits are gone, well, that doesn't necessarily mean that you have good feedback. You still need to analyze that plot and make a determination as to whether or not it's tuning that you need to go forward with, or if maybe there's still a wiring or a setup issue. Now, if we had gone through our startup guide, we wouldn't have seen any of these problems. Everything, would have been set up correctly. We would have gone step by step, and so we wouldn't have to do this troubleshooting, but that's not always how it happens. Maybe things are rushed. Maybe you're coming in on a project that you have never touched before. Many times things are amiss. So this is kind of everything is going wrong here. What I'm going to do at this point is I'm going to put us into simulation mode so we can start trying to move forward with this application. So I'm going to go ahead, I'm going to try to run my program again, and I'm going to start plotting here so we can see exactly what's going to happen. Okay, so we made it further than we did before, right? At least we're actually moving. I'm going to hide some of these elements. At least we're actually moving, right? Our actual position, it's starting to move. And our target position, it's starting to move as well. So we're going down the same path as before. Again, I'm going to look and see, well, what error bits did I have? Access tools, and I've got a following error. So if you're unfamiliar with the following error, that's fine. Let me just give you kind of a brief overview of what the following error does. So this is what we're seeing on our screen, seeing that we have a following error. You could kind of see what was happening there. You've got your actual position and you've got your target position. Once we get past our position error tolerance, we'll look at that here in just a sec. Once we get past this margin here, you get that following error bit to turn on. You can see for this application, the position error tolerance is set up at 1/4 of an inch. For us, it's going to be set up at 1 inch, just to make it a little bit more obvious what's going on. But you can see that this following error just tells you, hey, your target and your actual, they're not tracking very well. For some applications, maybe that doesn't matter. Maybe turn off the direct output halt for that, but we're going to say in this case that we want to track very tightly and on all portions of the move. And so let's try and fix this. Okay, so following error means we're not tuned up well. What we would do at this point is look at our gains and see where we sit, see what our starting point is. So I'm going to go to my plots, go over to my tuning tab, and I can see I've got a little bit of proportional gain, but that's about it. So the results that I'm seeing here, well, they're not so unexpected. This is what I would expect to see if I just have a little bit of proportional gain. There's a quick way to tune up this. If you're interested in going deeper with tuning, we've got some great webinars and help topics specifying, how to actually tune, how to get through. But for this, I'm going to just briefly go through it, and we'll go ahead and we'll see where we can get from there. So I could use an existing plot. I could use the auto tuning wizard. For me, this is kind of giving us a precursor of to other issues that we're going to start seeing in the future. But I'm just going to say use an existing plot. We'll say 2 plots, or we'll actually just do a single plot. We'll grab this one here. Now, since I just used a single plot, I only have one velocity feed forward. I don't have a positive and a negative. I won't get into too much of what that implies, but generally we want to have both positive and negative. It'll give you good control going forward and backwards. But for the purpose of this is going to be just fine. Okay, let's go ahead and we'll try to do our move again. Okay, so I have a new error. I didn't catch exactly what happened there. Maybe it was hard to see that bubble. I'm going to try to run this again. I don't see any movement. That's odd, right? Before we got a little bit of movement, we did our tuning, and now we're seeing nothing. So at first glance, that doesn't really make sense. It seems like we went opposite compared to what we should be. So if something doesn't make sense, if you're not understanding why things are happening, the first thing you want to do is look at Access Tools. I see that I've got a command modified error bit. Again, still, it's not really clicking. Why did we get this problem? Well, we're going to use our next tool for troubleshooting. You'll see that the 2 nicest tools for troubleshooting are plots and the event log. We've already looked at plots. We're going to go into our event log. So let's see what's happened here. Well, I've got my move absolute, right? Moving to a position of 10. That all looks good there. But then I see I've got an axis halted here. Okay, it says command modified. A lot of times it can be confusing. It's a little bit more clear, but sometimes if you've got a lot going on in your project, it can be a little bit confusing. If you see a halt, look at the steps that are immediately before it. So for us, it says requested position truncated at limit. Okay, so that makes sense. What that tells me is I need to look at my position limits. I need to see if they're set up correctly. So I'm going to go into Access Tools. I'm already in my my All tab here. I'm going to open up Target, and then I can see that I've got a positive travel limit and a negative travel limit. So I'm going to set this up. They're both set to 0. Now this makes sense, right? My position was truncated at the limit. It says you can't travel further. And the reason why we were able to travel before is because the controller will allow you to go closer to your limit, but not further from it. So I could go from where I started at a position of 15 down to 10, and that was okay because I'm getting closer to my limit. But I can't go from 10 to 15 or 10 to 25. It's not going to allow me to do that. It's going to give me an error instead. So I'm going to go ahead and I'll put in a position limit of 30. I'm going to download this, and we'll continue through through our task here. So let me try to run this program again. Okay, we got another problem. And I mean, this is just one problem after the next. If any of you guys have, experienced just a tough system to work on, it does seem like sometimes it's just one error bit after the next if everything is just not set up how it should be. So we've got a plot here. Perhaps again, maybe it's not immediately obvious what exactly is going on here. Go to my axis tools. I've got an output saturated bit. So what does that mean? I'm sure some of you are familiar with this. I'm sure you've run into it before. Again, open up my help topic, output saturated. If the control output exceeds the output limit, then we're going to get this bit. And so generally that output limit is going to be 100%, unless you've set it to something different. For us, it's 100%. So that tells me for one reason or another, I've gone past 100% for my output limit. Okay, let me just show you kind of how this looks here. I want to show just that the troubleshooting chart still works here, right? What is the problem? It's not moving or working. Are any of the error bits on? Yes, this error bit, the output saturated bit is on. It's moving, but not doing what it should be, right? It's moving, but we're getting a halt. Well, both of these here go to look at the commands coming through. What is actually coming through here? So plot the system and determine the problem, check the event log, and see troubleshooting tips help topic. So let's see if we can determine how to solve this from plotting the system and checking the event log. Okay, so I know what's going on here. I know that I'm going to 100%, and I can see that if I move my cursor right to the peak of this green line here, this is my output that's going to my system. I can see that I'm hitting 100% here. Well, perhaps this isn't really an issue. Generally, the output saturated is a nice error bit to have, but it doesn't look like there's really any damage happening to my system. I think everything's fine. I mean, it doesn't look like I'm running into the edge or I'm crashing into anything. If you're certain that you're not going to cause any damage to your system, one thing that you might do is go to your axis tools, look at your halts, your auto stop configuration, and you might say, well, I'm going to take this output saturated bit and I'm going to change it to a status only. So what that allows us to do is keep running even when we see that bit. So I'm going to download here. I'm going to move us back to a position of 10. And let's plot this and try to run our program again. Okay, so we get another problem here. We get a following error. We'll be able to see that here on our bits. We've got the following error here. And so I'm going to zoom in and I'm going to determine, well, what's going on here? I've used the plot. Maybe it's still kind of unclear, exactly what's going on, but it looks like my output here, right? My green line, well, it's all the way up at 100. It's staying at 100 here. And perhaps it's just not really clear. Why am I getting a following error? Why am I not able to track this? Well, let's look at our event log and maybe it'll shed some light on the situation. Okay, so here's our halt, following error. Again, what we do is we look at the step that's immediately before, move to a position of 25. That looks okay. Move at a speed of 50. That is not what we would expect, right? We were looking at our parameters in the beginning, and we said the max that we can move is 30. So something is already starting to, ring some warning bells here. It looks like that command is not correct. Well, as soon as I see that my command is not correct, what I'm going to do is jump into my program or whatever your source is for your programming and commands. It could be a PLC. For us, it's just going to be a simple program. So I'm going to look at my main program here, and I'm going to see what's going on. So I've got to move to a position of 10, 20, 100, 100. All of this is working correctly. If you're not familiar with our user programs here, we generally will have a command and then a link condition. The link condition is what allows us to move on to the next step. So for instance, with this step, I'm moving to a position of 10. My axis 0 is moving to a position of 10. Once my axis 0 is in position, this in position bit right here, I'm going to jump to my next step. So I can see that my next step here, well, I've got a speed variable. And this is actually a variable in RMCTools. So simple program, it's a fairly common setup. What I'm going to do is look at my variable table and see what this is. Well, I look at my speed. I can see that the initial value is 20. So maybe it's not clicking yet, right? Well, where is this speed of 50 coming from? It's not really making much sense. One thing that we can do is go back to our plot and send us back to 10, but I'm actually going to change this plot. I say, well, I would actually like to see not just the initial value, but I want to see what the current value is at the time of my program executing. So I'm going to put speed, open up my plots, I click new quantity, went to my variable table, and just about every single register in the RMC can be plotted. So I'm going to plot this speed variable in real time, and let's see what that variable ends up being. Okay, run the task. I can see motion profile and everything looks the same here, but my speed, I see, well, that's 50. It's odd. It's not making sense. Why is that 50? Well, let's go back to our variable table. And instead of looking at my edit tab here and just the initial value, let's go to the monitor tab. And you can see that my actual value is 50. So maybe this is getting set from a PLC. Maybe it's kind of erroneously being set to 50, and we need to change our process. We're going to say maybe someone just came in here and tweaked this value without us knowing. And so cross your fingers, hopefully that's the worst of it. I'm going to change this back to 20. Download to our controller. We'll go back to the beginning here, and let's try and run our main program. Okay, so our program ran, but we were expecting cycles. This doesn't really so much look like a cycle. It's more of just one move. So at this point, I'm going to go back into my my slideshow here, and let's talk about what we're actually hoping to achieve. So we want to get cycles like this. That's what I would hope for from my user program. It's set up so that the links will follow into each other, and this program should just continue to repeat endlessly. We're not seeing that. We're seeing what looks like the beginning of one cycle, and that's about it, right? So we want to move to 10 inches. Right here, this is 10. Wait until we're in position. Wait till we're at that position of 10. Then move up to 25 inches, right here. Wait until we're there. And then we want to repeat the steps. Well, what looked like was happening was we were moving to 10, then we were going up to 25, but we were just held there. So that's kind of where our problem lies. So let's go through our chart and see what we need to do. What's the problem? Well, it's not moving or working. Are any of the error bits on? For this, I don't see that there's any error bits on. It's moving, but it's not doing what it should be. It's tracking just fine. Hardware is just fine. But again, both the error bits and the moving and not doing what it should be, well, they tell us we need to plot the system, check the event log, see what's going on here. We know that the commands are coming through. We're actually getting movement, but let's see if we can determine what's going on here. Okay, so I've got a pretty good idea that my commands are coming through, but if I check my event log, well, I see that I've got a move to 10, right? As soon as I see that my task 0 started here, I've got a move to 10, a move to 25, and that's it. That's the end of our process. Um, Nothing really more is happening after that, so it's kind of it's unclear what we need to do next. Well, I'm going to look at my program here, and you can actually see that I've got a little red caret that points at the step that we're currently on. So I'm going to look at my link conditions, right? This link condition says wait for axis 0 dot status bits to be in position. Once this condition is met, we're going to jump down to our next step. And this program is nice because it's got little descriptions in each of these steps, so we know exactly what the logic should be. For step 1, it looks like this is a step that we're stuck on. If I look at my description, it says moves axis 0 to 25. Once in position, jumps to first step. Okay, so we've got our in position bit. Looks like it's jumping to step 0 here. That looks good. So why are we being stuck? I'm sure that many of you probably already see the problem in here. If you see it, go ahead, shoot it in the chat window. But I'm sure that I'll give you just a 30 seconds or so to see what the problem is and see if you can determine what we're going to do to solve it. Okay, so you had a second to think. What the problem is here is I'm moving axis 0, but I'm looking at the status for axis 2. Really easy mistake to make, and it's not always the most obvious that that mistake is happening. So I would change this to a 0, and click OK here. I'm going to download my user programs, and I've got an issue here. So let's see what the problem is. Got a problem here. So this is just a setup program. Let me go ahead, comment that out. So what I did there, that was something that was kind of unrelated. That was basically a program that I had to mess up all the parameters so that we could run through all the error bits, and that's where we were upset. But our main program here, it looks just fine. Able to download it, and we should be good to go at this point. Let's check and see if everything is correct. Start task 0. Perfect. Now we have the cycles that we were wanting. Everything looks good. We're tracking well. If I look at my axis tools, I've got no more error bits. Everything looks just fine. Now, that wasn't a long process. We did this all in 40 minutes or so. Troubleshooting Flowchart, very nice tool to get through this. Fairly simple application, but you can see how you can easily get hung up on one issue, right? Say, for instance, we didn't realize that our transducer wasn't connected like it should be. Well, we might be trying to fight with tuning and deadband and all kinds of other things when the real issue is we're not getting the feedback that we need. So following through this chart is a nice way to determine the issues and knock them out one at a time to get to where you need to be. One thing I would say is always start with looking at your error bits. Those bits are going to tell you that there's a major glaring issue. It's not going to catch problems in your logic, but it is going to catch larger problems that definitely need to be resolved before before you really dig deep into the logic and trying to make sure that that's correct. Okay, so again, this is a more basic troubleshooting webinar focused on a simple example. If you'd like something a little bit more in depth, we've got some great webinars that focus on some of the more advanced approaches to troubleshooting. Maybe you have a very complex, tricky system. I would highly recommend looking at our past webinars. Just a great resource there. Plotting, event logs, status error bits, and more, right? But these three main tools, plotting, event log, and status error bits, they're going to get you through 95% of your problems. Just using all of these are, it's a great way to start. So what's next? I want to just talk a little bit about the different controller options we have if you're unfamiliar with them, especially since we've just recently made changes to our lineup. Um, we've got the RMC 75, 1 to 2 axes, RMC 150, 2 to 8, RMC 200 Lite. This is the new one here, up to 18 axes with this controller. RMC 200 used to be 32, now it's up to 50 axes. So we've increased that threshold there. All of these controllers are using RMCTools, same program that we were using today, and the same troubleshooting techniques are going to work with any of these controllers in the family. So Delta has some great resources for you to use, knowledgeable Delta sales, technical support. Technical support is free, and very knowledgeable distributors. Application docs are available for many different applications. Say you've got a 4-cylinder press application. Well, we've got a paper for that. We've got a write-up. We've got specific examples, and many different things, whether it's presses, testing, die casting. We've got many different application docs, so feel free to reach out if there's something you need. And we also have a hydraulic design guide that AJ is going to talk about here in just a bit. Before we get into that though, are there any questions? Okay, well, if there are no questions, we'll go ahead, we'll jump into AJ, I'll hand it off to you.
Thank you so much, David. All right, so David mentioned we have a hydraulic design guide available that is a compilation of articles written by Delta President Peter Nachtwey. I'm sure some of you are familiar with that name. If you've ever been on plcs.net, Peter is pretty active in the forums talking about controls theory for hydraulic systems especially. You can request your free design guide by visiting us at deltamotion.com. And right on the main page there to the left side, you'll see this free design guide icon. And you can click there, enter your mailing information, and we'll send a copy of that right out to you. All right, I mentioned at the top that there are a couple of places where recordings are available. Recordings are available at deltamotion.com. You'll see the webinars link at the at the top of the screen there. If you click through that, you will be directed to the webinars page where recordings and links for registration for upcoming webinars are available. We also have a forum, discussion forum, and that's located at forum.deltamotion.com. You'll see a webinars link right there, front and center. Same deal. Recordings are available there as well as registration information for upcoming events. And then finally on YouTube, no opportunity to register for future webinars, but there are copies of all of our recordings as well as other video assets there. If you search for Delta Motion Control, all one word, you will find our home there on YouTube. Thank you so much. We hope you can join us next time.
Thanks, guys.